In this video, we will be talking about section 7.2, rational exponents. And basically what we're going to be doing is converting rational exponents into radicals. And by the definition of that, basically, is that if we see a base that has a rational exponent, aka a fraction, we can turn it into a radical. And what it says is that the denominator of the exponent now becomes the index, and the base becomes the radicand. Now, you might wonder where this 1 is going to go. Well, the 1's implied as the exponent of that base in the radicand. That can kind of help us when we're looking at other kind of rational exponents that don't have a numerator of 1. So, if we have an exponent, let's say a to the m over nth power, again, the denominator becomes the index, and the numerator becomes the exponent underneath the radical sign. So what we're going to do now is we're going to take a few of these examples and we're just going to change them into radicals, and then we're going to see if they can simplify. So with this 25 to the 1/2 power, I'm going to make my radical sign. The 25 goes underneath, 1 is my exponent, and my index is 2. So basically we have the square root of 25, which we know is going to be 5. Go ahead, pause the video, and work on 2 through 6, changing them into rational exponents into radicals and then simplifying them. In number 2, you should have the cube root of 27 to the 1st, which becomes then just 3. The cube root of 27 is 3. With number 3 over here, we have x to the 1/5. I'm going to make my radical sign. 5 is the index, and I have x to the 1st. Since there's no number to simplify, that is going to be in its simplest form, the 5th root of x. If I look at number 4, now this has to do with watching our negative signs. The 1/2 power is only connected to the 25. So I'm going to put the negative on the outside, then make my radical sign and do the square root of 25 to the 1st, which then will be 5, and then I negate that with the negative, so it's -5. In number 5 over here, I'm going to want to make sure I distribute that exponent to both both numbers and variables inside the parentheses. So remember that 27 does have an exponent of 1, so when I distribute it, it becomes -27 to the 1/3 power, and then the y to the 6 becomes y squared. 6 times 1/3 is 2. So then I'm going to go ahead and take the -27 to the 1/3, and that's going to become the cube root of -27, and that becomes -3, and then I'll drop down the y squared. And finally, number 6 is another one of those cases of just making sure we are careful about where the exponent's applied. The exponent is only applied to the x because there's no parentheses. So the 7 drops down, but the x goes underneath the radical, so it's going to be the 5th root of x. We're going to look at a couple more that don't have 1 as the numerator for the rational exponent and work from there. So if I take 9 to the 3/2, I can rewrite it as the square root of 9 cubed. 2 being the index going to the outside, 3 being the numerator becoming the exponent. Now, if I tried taking 9 cubed, that would be quite a large number, and then to try to figure out a square root of that number would be kind of hard. What can happen here is that I can actually kind of change these around. I can do the square root of 9 and then put the exponent on the outside, making it a little bit more easy to work with. I do the square root of 9, which is 3, and then I cube it, and it becomes 27. So again, go ahead and pause the video and work on the next 4, and then see if you get those right. Alright, for number 8, that negative sign again is not attached, so what I'm going to do is I'm going to negate the radical, the 4th root of 256, and it's going to be raised to the 3rd power. Now, neither one of these numbers is easiest to work with, but it's a lot easier to take the 4th root of 256 than trying to cube it. So let's take the 4th root of 256 and then cube that, which is going to be 4. And if I cube 4, that's going to give me 64, and I'm going to negate that, so I get negative 64. One thing that's going to be very helpful in the next few lessons is if you kind of make yourself a chart of perfect squares, perfect cubes, perfect force. That way, these numbers will seem common to you when you are asked to take the 4th root of 256, or if you are asked what's 4 to the 4th. So I would make a semi-comprehensive list, you know, maybe 5 terms of each squared cubed to the 4th. That will help you kind of recognize these a little bit more. Alright, number 9, we're going to take the 5th root of negative 32, and that's in parentheses, and it's going to be squared. Again, it's easier to take the 5th root of 32, negative 32, which is going to be negative 2, and then square that, and we're going to get 4. And if we look at number 10, like we talked about before, is that we apply things both to numerator and the denominator. So we're going to get 1 to the 3/2 power over 4 to the 3/2 power, and we're going to apply the radical to each. So it's going to be the square root of 1 cubed over the square root of 4 cubed. Numerator is just going to be 1. And if I look at the denominator, I'm going to do the square root of 4, which is 2, and then cube that, which is 8. So I'm going to end up with 1/8. And finally, number 7. I have this binomial in here, but that still applies. But because it's a binomial, I can't just distribute the exponent. It has to go together, stay together when I write it out. So it's going to be 2x plus 1 squared. I can't reduce the 7 over 2, so that's actually going to be our final answer. Alright, and now we're going to come to the end part of our video. We're going to talk about when we have a negative exponent, rational exponent. This shouldn't surprise you. It's the same sort of pattern that we've seen in the past. If I have a to the negative m over n, because it's a negative exponent, we move it to the denominator. So it's going to become 1 over a m to the over n power. And then I can make it into a radical by doing the square root of n a to the mth. And that's what we're just going to do in this one example. I'm going to make this a positive exponent. I'm going to change it into a radical to make it a little bit easier to work with. I'm going to do the cube root first to 27. That's going to be 3, and then I'm going to square it, so I end up getting 1/9.